Okay, hello everyone. Welcome to join today's training. Today's training, I will introduce the different type of temperature module. Uh, as you can see, we have expansion module and a DV module and the LCM module for temperature. First, I will introduce the LX3V4 PT temperature. This temperature can work with a PT100 sensor. So you can see how does the module look like. This module have the four channels, so you can connect it with four PT100 sensor. And when you use this module, you need to connect a DC 24 volt power supply. And we can see there also have the LED inductor in this module. It's here. And for COM inductor is to show the state of communicating. And when the DC 24 volt is connected to this module, the power lamp will be on. And the PT1 to PT4 shows the state of each channel. And the link LED to show the state of communication between the PLC and the module. This is the wiring of the different type PT100 sensor. If you have a 3-wire PT100, so you can connect two positive wire to the I1 plus and L1 plus, and the negative wire connect to L1 negative. But if your PT100 is just have two wire, just connect make a short connect between the L1 plus and I1 plus here, and connect the negative wire to L1 negative and the positive wire to Li and L1 plus. And don't forget to apply the DC 24 volt to this module. This is the convent characteristics for the LX3V4PT. So the range, the high limit is about 600 degrees Celsius, and the maximum digital output is 6,000. And our module both support both degree Celsius temperature and the degree Fahrenheit temperature. This is the buffer memory of the LX3V4PT. So BFM1 to BFM4 is the average temperature reading from this just the average temperature reading to be arranged. The default value is 8. And BFM 5 to BFM 8 is the channel 1 to channel 4's average temperature in degrees Celsius. The unit is 0.1 degrees Celsius. So if you get the value from BFM 5 is 300, it means the temperature is 30 degrees Celsius. And the BFM 9 to BFM 12 is the present temperature in degrees Celsius. And the BFM 13 to 16 is the average temperature for degree Fahrenheit. And the BFM 17 to BFM 20 is the present temperature, also in degree Fahrenheit. And for the BFM 29, it shows the error state. And the BFM 30 is the identifiable K2040 is the code for LX4PT. And the last BFM 31 is the soft version of this module. So this is the example program. The key part is how we can get the temperature value from the module. So the first, we need to set the number of SAMs. But default value is 8, so we can change it as 4. It depends on your requirement, and use from instruction to get the value. And let's see this example. So here I used LX5V to connect LX3V4PT module. And as we can see, we judgment the module we connect. So here is 2040 is the module code as here. So by using CMP instruction, if we connect the 4PT module we need, the M1 will be on. And here we set the number of SAMs. And now we can get the value. As you can see, I just connect one PT100 sensor to this module. So I only get the average temperature in channel 1. Here 271 means the temperature now is 26.1 Celsius degrees. And now here I have a glass of hot water, and now I put the PT100 sensor into the hot water, and you can see the temperature is rising rapidly. Also here. So as now we can see, the temperature of this water, this glass of water is over 70 degrees Celsius. So now I put the sensor out of the hot water. You can see the temperature is going down rapidly. Okay, let's move on. Let's introduce the LX3V4 LTC. This module is work with the other type temperature sensor. It can be used with many type the mockers. You can see type B, type N, type K, type E, type J, type T, and type B. Both and all of them are supported. And they have the same structure. It has a 4 temperature input port and the 4 transistor output port. The 4 input port is here. As we can see, channel 1, channel 2, channel 3, and channel 4. And also the 4th output channel. This inductor is also the same with the PT41. PT100. And this is the wiring. Also need to connect DC 24 volt power supply and connect the temperature input, the mockup to the terminal. And if we use channel 1, here is L1 plus and L1 negative. The output channel we should choose out 1. And this is also the conventional characteristic. This is the key buffer memory of this module. So we can see the BFM 0 is to choose the type of demographer to use the different value. And B1 to B4 is the different channels averaged contents of the filter. And we can get the average temperature in degrees Celsius in BFM5 to BFM8 for channel 1 to channel 4. And if we want to get a current temperature, just get a value from BFM 9 to BFM 12, and also support the degree Fahrenheit. And this module, I mentioned it before, it supports PID control. So this also have some key buffer memories for the PID control. As you can see, if we want to set the target temperature, we can set the value of BFM 45 and for channel 1. And if you use channel 2, you need to set the value of BFM 83. And for channel 3, the value is for the 121. And the same for the channel 4, you should set the value of BFM 159. And for the control output value, the different channel, the different buffer memories. For channel 1, it's 46, and for the channel 2, it's BFM 84. Channel 3 is for 122, and channel 4 is for 160. And we can start the PID control by list 4 BFM buffer memories. If you want to get more details about these buffer memories, you can visit our Wacom Support Center. Here is the detail, and you can see more bridges to adjust. For example, for the output up limit and low limit, and this mode also have the alarm function, and choose the different alarm mode and set the different value. Okay, this is the demo program for LX3V. So here we can see we set the target temperature is 80 degrees Celsius, and set the self-turning bias and the alarm mode, and to set the upper limit alarm and the lower limit alarm. And this part is for the initializer. And after that, we start temperature control. Just wait a moment, I will download the demo program for better demonstration. Okay, as we can see now, I connect LX3V for LTC module to LX5V. So let's see this program. At first, I set the target value, the target temperature. Here is the 37 degrees Celsius. And I set the self-turning bias and the range of PV, the output value. Here I set it as from the range is from 0 to 2000. And I also set the value of arm mode is 1. You can see it here. If I set the channel 1 arm, here I just set it as 1, so it means I use the upper limit alarm. So when the temperature is higher than I set, the arm value I set, it will trigger the alarm. So the alarm value here I set is 50 degrees Celsius. And we use TO instruction to write the value into the module. And here I use the mockup is type J, so I set BFM 0 is H3330. As you can see it. Type K. Type K, so I set it, the BFM 0 is H3. You can set other type for this 3 because I just used the channel 1 here. So I just confirmed the value of the last one. This part is to set the alarm mode and the alarm value. And BFM 57 and 56 is the sampling cycle. I set it as 4. And the BFM 59 here is the control cycle. I set it here 4, so it means 2 seconds. the control cycle here is 2 seconds. So at first, we initialize the module. And reset the error. And now we can see the module is get the environment temperature. Now it's 26, about 27 degrees Celsius. And then there's no control output now because I didn't start the control. And when I triggered FM 102, and as you can see it, the control output value is changed. So if the temperature is lower than the target temperature we set, here I set is 37 degrees Celsius. Sorry. Sorry, since something wrong with this computer. Since the connection I think I should re-download this project. Okay, since it's weird. Okay, let's restart it. And now we start control. And you can see now the control output, the value of control output is increasing because the temperature is lower than the target we set. So it will increase the output to heat the system. And if I turn this sensor into the hot water, as you can see, the temperature is going uply. So you can see now the control output is 0 now. Because the module noticed if there is no the system, if no output, the system still still raising. The system temperature is still going up, and it's out of the. It's higher than the temperature we set, and I put it out of the water, and you can see now the temperature is going down and the control output is increasing. So this module will provide a PID control function. And let me show you the alarm function for this module. So now I put the sensor into another higher, the hotter water. And remember we set the alarm value here is 500. So it's 50 degrees Celsius. And I get the PID event from BFM44 and send it the value to the D44. And as we can see it, BFM44. Here BFM44, and the bit 4 is the alarm 1. When the alarm 1 occurs, the bit is on. So this alarm is for the high limit I set here. So now the temperature is less than 30 degrees Celsius. So now I put it in the hot water. with the temperature increasing. And when he is over 50 degrees Celsius, and we can see D44.4 is on now. So if I cool down this temp sensor, so you can see the alarm is released. We can see it again. Hello, can you hear my voice now? Hello? Sorry, can you hear my voice now? Okay, a disconnect just now. So let me show you again. Okay, now I am back. Okay, let me show the alarm function again. Now the temperature is lower than 50 degrees Celsius. We set the degrees here, and the alarm mode, the up limit alarm. So I put the sensor into the hot water. The temperature is increasing. When it over 50 degrees Celsius, this bit will be on. Yes. So now I put the sensor out of the hot water, and the alarm released. So now, do you have any questions about this module, LX3V4LTC? So you can see the control output value is still changing based on the temperature, the current temperature now. And if the temperature is over, then we set, now it's 40 degrees. So the output is 0 now. You can set it here. So I set this. It's from 0 to 2000. So I write these two value into the here, into the BFM 63 and BFM 64. So here, these two. And you can see here, the last parameter here, I set K2 here, so it can write two address value. D263 to BFM63 and the D264 to BFM64. Okay, do you have any other questions? Okay, so let's move on to the BFM module. As we know, all the BFM the module we have is to use the model bus RTU and now we move to the BD module. BD module is much simpler than the expansion module. Just connect the sensor to different parameter to different terminal. So for here, LX3V2TC BD module. So it have two channels here. And it supports the type J and the type K sensor. And also have the LED lights to show the state for the power, for the communication, and the state of different channel. I just noticed if all the LEDs flashing, it means the firmware version of this PLC is not support. So this is the wiring. And for all the BD board, you can use the same special register to get the value and set the input mode. So if you have you want to get more information, you can also get it from our support center. We also have a LX3V2PT BD module. So you can also work with the PT100. Okay, it's not many differences with other BD module. So we can move on to the LCM module. As we know, all LCM module communicate with the PLC by the model bus RTU protocol. So here you can see this. Here is the terminal of the serial port. And it also needs the power supply here. Just remember, don't connect the power supply in here terminal. The correct terminal is here. And let's introduce LCM4TC module. As you can see, it supports type J and type K sensor and have 4 channels. Also, you can see the module state by the different indicators. So when the module is working normally, the link indicator is blink, and the communication indicator is also blink, and the TC indicator is off to show the analog input is in range, and the error indicator also off. This is the example demo for the LX3V. So for LX3V, we need to set the communication parameters by these special registers. So here is the list part. And we set the RS instructions parameters. So here, we set the station number is 4. So the higher word is 2 here. And if we want to get the value, the function code is 6. And if we want to read value, the function code is 3. So we use the RS instruction to communicate with the LCM module. Let's see it in a real program. Just wait a minute. I need to connect the module to the PLC. Okay, now let's see this demo. At first, we should set the communication parameters. So here I already set the bound rate is 9600 for this module, and the swap bit is 1. Priority is even. So don't forget to set the station number for this PLC. I set it as 1, so it means the PLC is the master station. And now we set the parameter of the RS instruction. I already set the station number here. The of this module is 2. So the upward is 2 here. And if I want to write the data, I set the function code is 6. And if I want to read the data, I set the function code is 3. And I use the type K sensor. So I set the last bit is 0. And set the different lengths of data. And at first we set in this instruction, we set which type of sensor we connect to the module. And then so here is BFM 0 to set the sensor type. Zero means type K, and the 3 here means not used. So in this program, I just connect one sensor, type K, in channel 1. And then we read the data from BFM 30. As we can see, we get the code of this mode to check is it K6030. Is it K630? If it matches, so the BFM1 will be on automatically. And we use RS instruction to get the value from BFM5. The BFM5 is the average temperature in degrees Celsius. The unit is 0.1 degrees Celsius. So here it says the average now for the environment is 25.9 degrees Celsius. And it also supports to get the value in the unit of degree Fahrenheit. The channel 1 BFM 30. Actually, I use as instruction to get the 4 value from each channel, but I just connect one sensor. And we can also get the error state from this module. BFM29 is the error state. So here I connect it, and I get the value from BFM29 to D11. And by using MOV instruction, we can match D10 to D25 of the BFM bit 1 to bit here, bit 1, bit 0 to bit 15. So as you can see, the M10 here is off, so it means bit 1, no error in bit 1 and bit 2 and bit 3. And the M20 is on, so it means the BFM29, the bit 10 shows the error. The digital output or analog input value exists on the range. Because this module have something wrong, so I cannot clear this error. Do you have any questions about this module? Just remember, if you use the BFM module, you are not longer to use FROM instruction or TO instruction. Instead of it, you use RS instruction, because you communicate with the module by Modbus RTU protocol. So if I put the sensor into the hot water, you can see the temperature also going up rapidly. And if I put it out of the water, the temperature is going down. This actually, when you use it, not too many different. It just triggered. You can wait a moment. No, DTO is the length of data, but TO and TOP it means the. Wait a minute, I'll show you. It means the instruction is plus type. So if here you use, for example, if you use TO here, when the M1 is on, this instruction will continue to get the value from BFM1 all the time, just when the M1 is on. But if you use TOP here, so when the M1 is from off to on, it will write the data to BFM1 just once. So if you want to change the value you write to the module, you need to trigger M1 twice for the second time. Okay, it's also the same for the from and the FROMP. It's also the same. You read the data from the module all the time or just once. For the length of data is for the D here. It's the differences from DFROM and FROM. It's for the bit length. Okay, do you have any other questions? Okay, if some questions reminds you occurred when you use these modules, just feel free to provide your questions in our group. So after the class, I will also made a after class exercise. So please submit it on time. Okay, and I will also share these 3 demo project in the group. So please check it. I think it will help you to better understanding of these 3 modules. Okay, so today's training is finished. Thanks for you to attend. See you tomorrow. Tomorrow the module is about the wiring. Waiting. Okay, thank you for all of you. Goodbye.